Good morning, students. In our last class, we are completing the complete chapter in unit number 2, chapter number 1. What is that chapter? Particularly, we are explaining Phonons theory. Nothing but phonons and vibration of phonons with respect to lattices. How many lattices we are discussing? One is complete monoatomic lattice is taken. In monoatomic lattice, only normal mode of vibrations are created with respect to phonon vibrations. After that completion, we can discuss with lattice vibrations, otherwise phonon vibrations in diatomic lattice. In diatomic lattice, more than one atom is existed. For more than one atom or one lattice point of view, their existing number of modes of vibrations are created. Particularly more than one atom, mainly two modes are created. One is acoustic mode, second one is optical mode, and both combinations also existed. So more than one atom, nothing but diatomic, triatomic, nothing but polyatomic. You can take the polyatomic molecules, their existing the modes of vibrations are mainly acoustic and optical mode. Acoustic mode is nothing but both the particles are moving along the same direction. Suppose the particles with respect to we are explaining transverse mode of vibration. One particles are moving upward direction, second particle is also moving upward direction. This type of vibrations can be called as acoustic mode of phonons. Suppose the particles, two particles are moving opposite in direction. One particle is moving upward, another particle is moving downward. Otherwise, one particle is moving right side, another particle is moving left side. Then type of vibration of modes can be called as optical mode. This type of vibrations are completely discussed in the chapter 1 of unit number 2. So in that way, density of states, group theory, group velocity, particle velocity, phase velocity, long range of wavelength, each and everything is completed in that chapter. So present, we are going to the next chapter, that is, what is that chapter? The chapter name is Free Electron Fermi Gas. Free Electron Fermi Gas. This is belongs to unit number 2. Particularly the chapter is second chapter. Unit number 2, chapter 2. First chapter is phonons and lattice vibration. So our present chapter is free electron Fermi gas. In that chapter, there existing number of topics are there. The first topic is energy levels and density of orbitals in one dimensions. That is the first topic. The second topic is free electron gas in three dimensions. And the third one is heat capacity. The third one is heat capacity of the electron gas. And topic number 4 is experimental heat capacity of metals. And the next topic is motion in magnetic fields. And also all effect. And Last topic is ratio of thermal and electrical conductivity. These are the topics belongs to our present chapter. Those are the topics or belongs to our present chapter. Approximately 6 main topics are existed. That is our chapter number 2 in unit number 2. The name of the unit in chapter 2 is free electron Fermi gas. First we are discussing topic by topic what is the meaning of the topic. After completion of clear discussion, we are going to the step by step, topic by topic. You can deep discussion can be covered. So present chapter is free electron Fermi gas. In free electron Fermi gas, how many votes are existed is nothing but here totally 3 votes are existed. 3 votes are existed. Particularly first and second vote is the combination can be taken. That is nothing but free electron. What are free electrons? First of all, we are discussing what are free electrons. So free electrons, particularly you know that electrons are existed. Electrons are existed in atom. Everyone knows in atom or atom. What is the meaning of atom? The meaning of atom is it is a combination of nucleus and electron. So every atom consisting of electrons. So the central part positive charge nucleus is existed. Around the positive charge the electrons are revolving in a elliptical orbit according to Sommerfeld electron theory. According to Bohr's theory, the shape of the orbit is circular orbit. These topics are covered in modern physics also. So according to the atom, it is nothing but combination of nucleus and electron. So every atom consisting of electron. Now, but according to our chapter, there is no need of electron. We need the word is free electron. What is free electron? Generally, in lower standards, free electron is nothing but outermost electrons can be called as free electrons. In simple language, the outermost electrons is nothing but valence electrons. Outermost electrons, otherwise simply called as valence electrons, can be called as free electron. What is meant by free electron? Free electron is nothing but the central part of the atom is nothing but positive charge nucleus is there. So around this there existing number of orbits are existed. So in this number of orbit, the outermost orbit electron has very weak interaction forces existed between central nucleus and outermost electron. You can give very low amount of energy. This electron is unbounded from the nucleus. That unbounded electron can be called as valence electron, simply called as free electron. So nothing but there is no influence of nucleus in the atom. That no influence existed in the atom of electron can be called as free electron. Those free electrons can move very freely. That movement of free electron is fastly. That fast movement of electrons in the outermost orbit can be called as free electron. That is the meaning of free electron. Free electrons is nothing but outermost valence electrons in the atom. Those are called as free electron. That is the meaning of free electron. What is the next word? The next word is Fermi gas. What is Fermi gas? So in the Fermi gas, there existing gas. What is it? What is gas? According to the kinetic theory of gases, gas is nothing but the atoms or electrons are existed in free state. There is no influence of side by side electrons and atoms. Nothing but number of free electrons is existed in the unit volume or particular prescribed volume, that number of electrons existed state can be called as gaseous state. It can be called as gaseous state. There is no existing of bounded force in between the electrons or atoms. That is called as gas. So gas is nothing but their existing number of electrons. So particularly this gas can be converted into Fermi gas. What is Fermi gas? The particular these electrons or atoms which obeys the Fermi Dirac statistics. Fermi Dirac statistics. That free number of electrons obey the Fermi Dirac statistics. Then that number of free electrons can be called as Fermi gas. Then that number of electrons can be called as Fermi gas. Best example for Fermi gas: electrons, neutrons, so on. The combination of electrons, neutrons, protons, that is the combination. That will set of lot of electrons combination can be called as Fermi gas. So the electron set obeys the Fermi Dirac statistics. Then the Fermi Dirac statistics obeys the number of electrons. That set of combination of electrons or free electrons can be called as Fermi gas. Can be called as Fermi gas. That is the main meaning of free electron Fermi gas. So out of the complete name of the chapter, in this chapter we can discussing about particularly Fermi gas. What is Fermi gas? The number or set of free electrons, the set of free electrons which obeys the Fermi Dirac statistics. Fermi Dirac statistics. Those are fermions. Those electrons, that gas atoms can be called as fermions. Best example for fermions are set of electrons, neutrons, protons, so on. So in this chapter you can clearly explained or explaining about Fermi Dirac statistics. That is the complete meaning of free electron Fermi gas. That is the first meaning. In that chapter, we are discussing approximately 6 topics are existed. First topic is energy levels and density of orbits, in particularly in one dimensional. So what is one dimensional? You can explain the topic. You can explain the motion of the electrons in only one dimensional. Particularly in a solid state physics, every crystal can be explained in 3-dimensional point, because the crystal basic definition is set of periodical arrangement of lattice points in 3-dimensional point of view. The set of or periodical arrangement of lattice points in 3. So every crystal can be explained in 3-dimensional point. But in our topic, you can explain all the properties with respect to 1-dimensional. So 1-dimensional is nothing but in space we have how many directions are there? You have 3 directions: x direction, y direction, z direction. So according to the coordinate system, they have the 3 direction. But according to the relativistic quantum mechanics, there are 4 quantities are there: x, y, z, and time quantity. Very important quantity. According to relativistic quantum mechanics point of view, they have the 4th dimension is existed. That 4th dimensional quantity is called as time. But according to the except relativistic quantum mechanics, the time factor can be taken as constant, because each and every point with respect to time we are expecting. So every point of view, the time must be constant. So in classical mechanics point of view, Newtonian mechanics point of view, kinetic theory of gases point of view, quantum mechanics point of view, statical mechanics point of view, modern physics point of view, in every aspect you are considering the time function must be constant. On that way, you cannot introduce the time factor. We are cannot introducing the time variable. Time factor cannot be introduced. Suppose in relativistic quantum mechanics, nothing but you are existing one frame of reference, nothing but with respect to earth frame of reference. You can explain the another frame of reference, nothing but you can explain with respect to moon point of view. So there existing two frames of reference with respect to different planets. In different planets point of view, the time function must be valuable. With respect to considering the time function, you can consider the time function. The depending on time function point of view, there existing one value in earth gravity and another value in moon gravity. So time function changes, values can be also altered. The altered case can be explained with respect to time function. That is can be taken as fourth dimensions. So four dimensions are existed, except this fourth dimension can be considered in at what condition you can consider relativistic quantum mechanics point of view. In this relativistic quantum mechanics point of view, you can take the reduced mass system is also taking. What is reduced mass? Mu is equal to mu naught by square root of 1 minus v square by c square. The relativistic or reduced mass system mu is equal to m naught divided by square root of 1 minus v square by c square. With respect to relativistic quantum mechanics point of view, you can take the reduced mass system. So because you can consider the time factor, that the particular physics can be called as relativistic quantum mechanics, except remaining all physics, you can take the time function must be constant. Time function must be constant. But according to our chapter, free electron Fermi gas point of view, you can explain one dimensional point, you can explain, and also three dimension is also explained. What is one dimension and what is three dimension? One dimension is nothing but you can explain the free electron state with respect to either x direction or y direction or z direction. Any one direction can be explained, then the motion, then the explanation completely belongs to one dimension. You can take the combination of three dimension, that is nothing but you can explain the quantity term with respect to the quantity term with respect to space with nothing but three dimensional point of view, you can explain it. Three dimensional point of view, you can explain it. So in that way, you can explain the energy levels and density of orbits in the one dimension. So all properties with respect to explain either x direction or y direction or z direction, as you wish. You can take any one direction, you can explain the all characteristics of energy levels and density of states of Fermi gas. So in each and every topic you can consider the Fermi gas. You can consider the Fermi gas. What is Fermi gas? The fermions obeys the Fermi-Dirac statistics, then the fermions can be called as Fermi gas. In the Fermi gas, the properties can be explained with respect to energies, ground state, first excited state, second excited state. So in that way, energy levels point of view and how many electron or how many Fermi gas is existed with respect to energy levels. What is the density of the electron? How many Fermi gas is existed can be explained. That can be explained with respect to either x or y or z direction point of view. That topic belongs to Fermi energy levels and density of state with respect to one dimension. That is the first topic. And the second topic, you can explain Fermi electron gas. You can explain the Fermi electron. I think but complete properties you can explain it. In what direction? You can explain the characteristics of the Fermi gas or fermions with respect to three-dimensional point of view. You can take three-dimensional, both x, y, z, and nothing but combination. You can take the combination of three directions. That three directions, in the three-dimensional point of view, you can explain the complete properties. What the properties? You can explain the properties of Fermi gas. So the Fermi-Dirac statistics at what condition obeys? Along the x direction condition, y direction, z direction, that complete three direction you can mix it or combined. That combined topic explained with respect to Fermi electron gas in three dimensions. That belongs to second topic. After completion of one dimensional point and three dimensional point, and the next topic is heat capacity of the electron gas. What is the electron gas? Electron gas is nothing but Fermi gas. So in that case, you can consider the Fermi-Dirac statistics. Based on Fermi-Dirac statistics, you can explain the heat capacity. You can explain the heat capacity in lowest standard, nothing but 10th, inter and degree point of view. Each and everyone knows the heat capacity. What is heat capacity? What is heat capacity? Heat is nothing but energy. Heat is nothing but energy. Capacity is nothing but the rate of doing work. So, according to heat capacity point of view, we can explain the definition. What is heat capacity? The minimum amount of heat energy required to rise the temperature of the body by 1 degree centigrade. The minimum energy of heat required to rise the temperature of the body by 1 degree centigrade. Suppose you have the Fermi electron gas. This electron gas is existed at suppose at 11 degrees centigrade. You can give the heat energy by rising the temperature. By using the temperature, the body of temperature is changes to 11 degrees centigrade to 12 degree. Nothing but the temperature is raised by exactly 1 degree centigrade. For particularly to rise the temperature by 1 degree centigrade, what you need? The absorption of energy is needed. The absorption of energy is given by using of heat. By using of heat in the form of temperature. The minimum amount of heat required to rise the temperature of the body by 1 degree centigrade. That absorbed minimum heat can be called as heat capacity. This particular term can be explained with respect to Fermi gas. So, in that body condition point of view, we can take the electron gas. You can give the extra energy by using or by rising the temperature. The electrons are moving in random direction. In that random direction, the temperature of the body is increased by 1 degree centigrade. Then the minimum energy required. To rise the body or Fermi electron gas temperature by 1 degree centigrade. In that point of view, particularly the concept is applicable to heat capacity of the electron gas. Heat capacity of the electron. That is our third topic. After that, completion of third topic, the next topic is experimental heat capacity of metals. Heat capacity of metal. So, in that point of view, you can explain the heat capacity. What is heat capacity? The energy or the heat energy required to rise the temperature of the body by 1 degree centigrade. That minimum amount of heat required is called as heat capacity. This heat capacity is explained on what the condition. You can take the metal. So, what is metal? Metal is nothing but a material. Metal is nothing but a material. Based on electrons, particularly free electrons, materials can be classified into, according to textbook point of view, 3 types. One is conductors, second one is semiconductors, third one is insulators. So, based on, you can depending on the free electron of the material. Depending on the free electrons in the material, the materials are classified into, according to the textbook point of view, materials are classified into 3 types: conductors, semiconductors, insulators. According to the concept point of view, depending on free electron state, materials are classified into 4 types. The fourth material is called as superconductor. So, these 4 are classified by depending the quantity, particularly free electrons, in the material. How many free electrons are existed? Depending on that number of free electrons, that material name is either conductor or insulator or semiconductor, otherwise superconductor. So based on free electron. What is free electron? According to free electron is nothing but in this chapter you can consider the Fermi gas. You can consider the Fermi gas. So depending on Fermi gas, how many free electrons are existed? Depending on the number of free electrons, you can classify materials are divided into 4 types. Conductors, insulators, semiconductors, and fourth one is superconductors. So particularly why you are choosing this topic, you are explaining the metals. Particularly you can explain the material, particularly metals. What are metals? Metals are the best example for conductors. Metals are the best example for conductor. What are conductors? Conductors are the materials. Conductors are the materials which consisting of number of free electrons. Which consisting of number of free electrons. What is that? So according to the material point of view, the first type can be taken as conductors. What are conductors? These are the materials. These are the materials which consisting of number of free electrons. Which consisting of number of free electrons. Those materials having the number of free electrons in high state, then the materials can be called as conductor. The best example for conductors can be taken as all metals in the nature, as you wish, any metal, iron, cobalt, copper, nickel, as you wish. So in competitive exam point of view, the liquid conductor can be taken. What is liquid conductor? The best liquid conductor can be taken as mercury. Mercury is the liquid conductor. Pure water is also conductor. Pure water is also best example for conductors. Those are the water conductor. The conductor is nothing but a material. Material consisting of number of free electrons. Best example for conductors can be taken as all metals in the nature. Mercury is the liquid conductor. Pure water is also the good conductor of electricity. After that, you can take one more material that is called as insulator. What is insulator? The material consisting of low concentration of free electrons. Low concentration nothing but very very low value. Suppose which consisting of number of free electrons, nothing but here very high concentration. High concentration can take here 1000 of electrons is existed, here only 10 electrons is existed. Nothing but the material of insulator consisting of very very low concentration of electron. Low concentration nothing but not the zero. They have the very very few free electrons are existed. Few is nothing but very very low. Nothing but according to the conductor here thousands of electrons of free electrons are existed. According to based on 1000, 10 electrons is very very low. So very very low concentration of free electrons are existed. Then the material is called as insulator. The best example for insulator can be taken as wood, rubber, plastic, etc. And one more device is called as semiconductor. The semiconductor, each and in this name is also known, semi is nothing but half. So semiconductor is nothing but half conductor. What is half conductor? Based on first conductor, the material consisting of high concentration. High concentration nothing but half of the high concentration. Half of the high concentration nothing but they have the free electrons which lie in between conductor and insulator. The free electron state is lie in between conductor state and conductor state and insulator. In conductor state you know 1000 electrons, in insulator 10. Nothing but in semiconductor there existing approximately some 700 is existed. 700 is nothing but which is lie in between below, which is lie in between below 1000 and greater than 10. So lie in between. So then the material is called as semiconductor. In the nature, the best semiconductors are only mainly two. One is silicon, another one is germanium. Silicon atomic number is 14, germanium atomic number is 32. The outermost configuration which beats NS2, NP2 configuration except carbon. So NS2, NP2 configuration is belongs to the semiconductor configuration. So that is the main. One more material is also called as, that is superconductor. What is super? What is the meaning of super? It is also the conductor, no doubt. It is also the conductor. So conductor can be explained in super state. So each and everyone knows differences between each and everyone and very much interest in movies. So how the movies are classified? How the movies are classified? So the movies can be classified. Each and everyone knows hit, flop, super hit, mega hit, bumper hit, so on. So depending on that, movies can be classified depending on number of working days in the theater. So number of working days you can consider 100 days. So below 100 days working day is nothing but flop. Exactly 100 days is nothing but hit. More than 100 days is nothing but super hit. Flop, hit, super hit. What is the meaning of super hit? Greater than the hit working days. In a similar way, conductor, superconductor. Conductor is nothing but 100 days working day. Superconductor is nothing but more than 100. Conductor is nothing but you have the high amount of concentration of free electrons are there. More than 100 more than high concentration. More high concentration of free electrons are existed, then the material is called as superconductor. Nothing but according to the superconductor, this superconductor can be explained particularly at low temperatures, which is very important. Superconductors mainly explained at low temperature. Remaining three materials can be explained at room temperature. So superconductors can be explained at low temperature. At low temperature, the conduction is existed with respect to pair of electrons. In conductor, there existing only flow of single electron. Here the flow is one electron is flowing, after that second electron moving state, after the third electron. One by one electrons in moving, particularly in conductor state. Particularly in superconductor state, pair of electron, 2-2 electron combination. So here one electron is moving state, particularly at that time there existing 2 electrons. Here 2 electrons is moving state, at that time there existing 4, more than. So pair, 1 is nothing but 2, 2 is nothing but 4, 4 is nothing but 8. So in that way pair of electrons is moving. So pair of electrons is moving. So the combination of pair of electrons is moving, large amount of current is flown. That large amount of current is existed particularly at low temperature. Then that material can be called as superconductor. The best example for superconductor is mercury. The first superconducting state can be explained by using the mercury element at particularly 4.17 Kelvin. Low temperatures you must explain superconducting state. That superconducting state is applicable particularly mercury at 4.17, which is approximately can be taken as 4.2 Kelvin. So at low temperatures you can explain the conducting state. The conducting state can be called as superconductor. This superconductor, which is our unit number 4. So clearly explain superconductors in further unit, that unit number 4. In that way you can discuss them clearly. That is why you are choosing this classification is nothing but here metals are existed. What are metals? Metals are the best example for conductors. What are conductor? Conductor is nothing but they have, the materials have high concentration of free electron. That high concentration of free electrons can be called as, we are taking Fermi gas. We are taking Fermi gas. So in that Fermi gas point of view, particularly we can explain the heat capacity with respect to conductor according to the experiment point of view, not the theoretical notation. You can explain the heat capacity in conductors, particularly experimental, you can explain it. Particularly in theory point of view, this before topic, heat capacity of the Fermi gas we are explaining. Heat capacity can be explained. What is heat capacity? The minimum energy, heat energy required to rise the temperature of the body by 1 degree centigrade. The topic is completely theoretical notation. This below before topic. Particularly this topic, that heat capacity can be explained with respect to experimental point of view. That experimental point of view can take the material, particularly metal. You can explain the metal heat capacity. That is called as topic number 4. After completion of topic, you can explain next topic, motion in the magnetic field. Motion in the magnetic field. Each and everyone knows Fermi gas is nothing but the existing number of free electrons. There are free electrons which are in moving state. Every moving electron or charged particle around, they are existing the magnetic field. The magnetic field can be explained, particularly the topic number 5. Based on this motion of the magnetic field, we can prove experimentally. The motion of the magnetic field is proved experimentally. That experiment can be called as Hall effect. That experiment can be called as Hall effect. So the electrons are moving in one direction. So electrons are moving is nothing but you can create the electric field. So one direction from left to right, they can create the electric field. Particularly this electric field point of view, perpendicular to the magnetic field is created. Every charged particle around there can create the magnetic field. That electric field and magnetic field both are in perpendicular direction. The most of the charged particle is also perpendicular to each other. So most of the charged particle, electric field direction and magnetic field direction, these three are mutually perpendicular to each other. This is can be proved by using the Hall effect. This is the experimental evidence of motion in the magnetic field. That is the topic number 5. After completion of topic number 5, you are going to the ratio. What the ratio can be explained? Thermal and electrical conductivity. Electrical conductivity is nothing but sigma. What is conductivity? The reciprocal of resistivity is nothing but conductivity. Otherwise, the flow of electrons per unit interval of time. The flow of electrons particularly in the unit time, unit area of cross section, that is called as conductivity. Another definition is, what is another definition? The reciprocal of conductivity. That reciprocal of conductivity can be called as electrical. In the same reciprocal of resistivity can be explained with respect to temperature. With respect to temperature, that conductivity is called as thermal conductivity, which is indicated by letter K. So first you can explain thermal conductivity. After that you can explain the electrical conductivity. Derivation completed, you can get the result, some value of sigma and some value of K. You can, according to the topic, those two values can be taken in the ratio. Nothing but K by sigma can be calculated. So after completion of thermal conductivity and electrical conductivity, clearly you can explain the ratio of thermal conductivity. These topics are belongs to present running chapter. What is the present running chapter? Free electron Fermi gas. Fermi gas. These topics can be explained in deep with respect to derivation. After completion of derivation, you can conclude the topics also. So, according to our chapter point of view, Fermi gas is existed. What is Fermi gas? The gases are non-interacting particles which obeys Fermi-Dirac statistics. Those non-interacting particles can be called as fermions. The best example for fermions can be taken as electron group or combination of electrons, neutrons, so on. So, in that chapter, you can explain the electrons. You can easily take in the electron. Why you are taking the electron? Charge of electron is known, mass of electron is known, characteristics of electrons is known. So each and every one electron can be known. On that way, you are taking the electrons. If you're not interested about the electron, you can take other neutrons, anyone. So you can take fermions. You can take fermions. Fermions nothing but those are non-interacting particles which obeys Fermi-Dirac statistics. Fermi-Dirac statistics. In that way, each and every topic must be explained step by step. Each and every one explained in step by step. That is about brief introduction about your Fermi gas. So in that Fermi gas, in our lower standards, maybe degree, nothing but B.Sc final year, B.Sc final year, paper number 4, B.Sc final year, paper number 4. Semiconductors are there. Last chapter, semiconductors and semiconducting devices. In that topic, they have one word is known, that is Fermi energy level, which is indicated by EF. What is Fermi energy level? What is Fermi energy level? According to the lowest standard or every point of view, Fermi energy level nothing but it is the topmost completely filled energy level at absolute temperature. Absolute temperature nothing but at 0 Kelvin, at absolute temperature. Then that energy level, is called as Fermi energy level. That is, so Fermi energy level must be explained at absolute temperature. There is no necessity for room temperature. So you must explain at absolute. So nothing but 0 Kelvin. So what is that? The topmost completely filled level. The topmost completely filled. For that case, we are explaining by taking the example. I am taking sodium. The atomic number for sodium is 11. The electronic configuration is 1s2, 2s2, 2p6 and 3s1. So according to the electronic state, by using Pauli's and above principle, you can fill in the electron state. Based on filling state, here there existing 3 orbits. One orbit, second orbit, third orbit. So positive charge nucleus, first orbit, second, third orbit. In first orbit, there are existing 2 electrons. First electron, second. In second orbit, totally 8 electrons. First, second, third, fourth, fifth, sixth, seventh, eighth. In third orbit, there is existing only 1 electron. So according to the sodium point of view, there existing valence electron or free electron. That free electron is nothing but 3s1 electron can be taken as free electron. This 3s1 electron is very weak interaction with the central nucleus. This weak electron can give the very low amount of energy. This electron can be free to in the orbit. So that is called as free. So according to energy level, the first orbit energy level, second orbit energy level, third orbit energy level. Each and everyone knows from ground state to higher state, the energy gap is increasing. So in the first, how many electrons are there? Only 2 electrons. So one is clockwise direction, another one is anti-clockwise. In second orbit, how many electrons? 8 electrons. Clockwise, first you can fill the clockwise direction electrons, after that anti-clockwise. So totally 8 electrons are filled in third state. So this is the energy level diagram. According to our definition point of view, the topmost filled level. So in our energy level diagram, the topmost level is called as third. Third orbit is the topmost orbit. The third one is the topmost. So according to definition, the topmost completely filled level. Here the third level, third orbit is completely filled, nothing but it is not completely filled, because in third orbit, how many electrons are filled? 3s, 3p, 3d. In s orbit 2, p orbit 8, d orbit 10. Totally p orbit only 6. Px, Py. So totally how many electrons? 18 electrons are filled. Totally 18 electrons filled is nothing but completely filled. So according to the sodium, in the third orbit only 1 electron. So this is uncompletely filled level. Incomplete. So according to the definition, the topmost completely filled. So the topmost level is nothing but third orbit. This third orbit is incomplete. After that, according to the incomplete plate, you cannot constrain. You are constraining only complete filled level. So based on third level, this is incomplete. Based on this, what is the complete next complete level? The next complete level is nothing but second. So because in second only 2s and 2p states are there. In 2s 2 electron, p 6. Total 8 electrons. So 8 electrons are occupied and are completely filled. So according to the definition point of view, the second energy level is called as Fermi energy level. According to the definition point of view, the second energy level of the sodium atom, according to the second energy level of the sodium atom, can be called as Fermi energy level. These filling states must and should be explained at what level? Particularly at particularly at absolute temperature. So at absolute temperature, the topmost completely filled energy level can be called as Fermi energy level. So Fermi energy level must and should be explained at absolute temperature point of view. You can explain. That is called as Fermi energy level. So according to sodium point of view, the second orbit or second completely filled level. So the second orbit is completely filled as compared to third orbit. So the second energy level can be called as Fermi energy level. That is the main point of Fermi energy level. This is the basic introduction about our present chapter, that is free electron Fermi gas. Okay, this is the basic introduction. So in our next coming classes, you can explain topic by topic. So every topic there existing some derivation, large amount of derivation is there. Based on complete derivation, you can conclude the topic by topic. We can conclusions are very important. According to the exam point of view, derivations also important. So according to quantum mechanics, Schrodinger wave equation is derived. Based on Schrodinger wave equation, you can go through the subtopics. So in every topic point of view, we are using Schrodinger's wave equation. Schrodinger's equation. So in our next topic, we can explain the topic by topic. So you must just recall the quantum mechanics, particularly what is Schrodinger equation, derivation of Schrodinger equation, what is the solution of equation, what are the constraints of the Schrodinger equation. Each and everyone knows boundary condition, limiting boundary and extended boundary. Each and everyone, just you can once you recall it. Based on recalling, I am explaining topic by topic. First, we are explaining the allowed energy levels. Okay. In our next class, we can explain the first topic. Okay. So completed. So this is the introduction point of view. Our present chapter, free electron Fermi gas, is completed. So you can explain the topic by topic. First topic is allowed energy levels. The first topic is allowed energy levels. So you recall the Schrodinger wave equation, complete derivation, each and every conditions in quantum mechanics. Okay.